Welcome to episode 5 on this deep dive series on vSphere with Tanzu. Now, we've been on quite a journey so far, so let's just quickly recap what we've done in the prior 4 videos. Episode 1 focused on all of the prerequisites, making sure the network fabric is set up correctly, making sure the routing is appropriate, and just explaining all of those requirements for bring your own networking. Episode 2 focused on how to set up a whole new vSphere cluster correctly configured and ready for workload management. Episode 3 looked at the enablement of the workload management feature in that vSphere cluster, including setting up HA proxy as a load balancer. And episode 4 contained what I call the good stuff, which is creating a namespace and then the vSphere admin handing over to the Kubernetes cluster admin to log into that namespace and then create an upstream Kubernetes cluster in that namespace. So where does that leave us right now? Well, it leaves us as the Kubernetes cluster admin with this new Kubernetes cluster that I've just created. And now I want to actually just try it. I want to run some sanity checks to make sure that everything's set up correctly and that if I were to hand this over to a developer, they'd be able to get on with it just fine as well. Before we move on, a quick caveat about this video. Having finished it, it's become clear to me that it's pretty dense. It's got a lot of information in it. And what I would advise is not necessarily going through it from start to finish, but rather looking at the agenda that I've set out and using the links in the video description to just treat it as a reference so that you can take one bit at a time at your own pace. And then if you want to, you can just link to it and come back to them. Okay, so let's dive right in. Now, the very first thing I'm going to do is to delete the Tanzu Kubernetes cluster that I created at the end of video 4. And the reason I'm going to do that is because I've done a bunch of things with it since, and I just want to make sure that I'm starting from a completely clean slate so that my experience will be exactly the same as your experience. And it also gives me an opportunity to show you how easy it is to lifecycle manage a Tanzu Kubernetes cluster. So the very first thing I'm going to do is to log in as the Kubernetes cluster admin. Now, the script that I'm using and everything else that I'm going to be using is in my GitHub repo, which I've updated recently. You'll see everything in there. And so just bear that in mind. That's corib/vSphere with Tanzu demo. Okay. So my password is VMware bang23. Okay, so I'm logged in. Now, if I do kubectl get tkc, it should show me the Tanzu Kubernetes cluster. There it is, simple cluster. So what I'm going to do is I'm going to just do delete tkc simple cluster. That is just going to wipe out the cluster. It's going to delete the VMs and give me a completely clean slate. Now this operation is synchronous and it takes a little while because it doesn't return until the virtual machines have been deleted. Okay, there we go. The virtual machines have now been deleted. And what I can do is I can recreate the cluster. So kubectl apply-f, and there should be tkc simple cluster 117.yaml. Okay. And there we go, a new cluster created. Now I'll focus in a subsequent video on other lifecycle management operations that you can do, such as upgrades, such as swapping out nodes, increasing the number of nodes, that kind of thing. But for now, let's just fast forward until we get this cluster up and we can start running some validation tests in it. All right, I'm back with a cup of tea, and let's see if we have a cluster. Okay, we do. Before we move on, I quickly want to call out an important blog post by William Lamb. Now, of course, William's blog is amazing, and in the last 2 or 3 weeks, he posted this, which is basically how to do what I spent 4 videos describing in a much, much easier way, just to have something that you can play with. And he's figured out how to deploy a very simple home lab into 32 gigabytes of memory. I haven't tried this yet, but if you really want to just get to this point that we're at right now in video 5 as simply and as quickly as possible, that's one way to do it. Okay, so let's start running some validation tests. Now, I've come up with a list here of some sanity checks, some validation checks. And this list isn't a definitive list, but it's just the kinds of things that you might want to do to just verify that your cluster is functioning correctly. And what I've done is I've encoded these checks into a bunch of scripts with some associated YAML that I put in my GitHub that I called out earlier. They're all in this sanity folder. You'll see the YAML for each of the tests and then scripts that you can run. And the first thing I'm going to do is log into my new cluster. Now remember, previously I was logged into the supervisor cluster, which is what I used to create this Tanzu Kubernetes cluster. Now that I'm logged into the cluster, I should be able to do get nodes or something like that. Yeah, there we go. So I'm logged into the cluster. All right, without further ado, I'm going to run my first sanity test, which is just to create a simple object in this Kubernetes cluster in the default namespace. Now, one of the simplest objects you can create is a config map. So let's do that. Sanity and config map.yaml. You'll see we're just going to create a very, very simple config map. Okay, it's created a config map, and I can do kubectl get config maps, and there it is. Well, what have we learned from that? I mean, I already authenticated with the cluster. I was already able to see the nodes. So, what was the point of just creating a config map? Well, the thing you have to understand about a Tanzu Kubernetes cluster is it operates on the principle of least privilege. And what that means is that it uses role-based access control to limit what users can do. Now, Kubernetes does this with a combination of cluster role bindings and cluster roles. So if we do kubectl get cluster role bindings, we'll see that in here there's actually a cluster role binding for the K8s cluster admin user. Now, this is one of the paravirtual features of a Tanzu Kubernetes cluster, that any namespace user that is given an edit role automatically appears in here with a cluster role binding. And let's just examine that cluster role binding and see what it allows us to do. So we can see that the K8s cluster admin at vSphere.local user has been given the cluster admin role. And let's have a look at that cluster admin role. As you can see, as a cluster admin, I could do pretty much anything with this cluster, and I can list other cluster roles to see what's available. You'll see there's quite a few cluster roles installed out of the box. Now, most of these are for the purposes of just the cluster operation, things, for example, like CNI. But you'll see also there's a couple of pod security policies that are defined here, and we'll be talking about those a little bit later. This next test is going to stand up the simplest pod we possibly can in our cluster. And it's designed to test two key things. Firstly, that we can pull images into our cluster. And secondly, that we have a pod security policy that's going to allow us to create containers inside of a pod. Now, let's have a look at the script that we're going to run. Now, you'll see the script uses the kubectl run command rather than applying any pre-existing YAML. And that is honestly the simplest way to run a container. It's very much like the Docker run command, quite honestly. It's a Kubernetes equivalent. You just specify an image, you can specify some parameters, and Kubernetes infers the pod YAML that you want for your pod, and it will start the container in the pod. And the key point is that it starts it using the user ID that invoked the command, which in this case is the Kubernetes cluster admin. So it's a very, very simple way just to make sure that you can stand up a pod. Now, you'll notice a couple of other interesting things in here. I've written some utilities that wait for certain conditions to be true before scripts proceed. So in this particular case, it waits until the pod has been created before it proceeds to say pod started and then suggests you open your browser. So let's run this and see what happens. Okay, I'll just highlight that and run it. Okay, so it's waiting for the pod to be created and hopefully. Excellent. Okay, that's great. So that started really quickly. Now we can cut and paste this, put it into our browser. There it is. Good. Thumbs up. We can create a container. We can pull images, at least in this particular case, we can pull images from the Google public image registry. And we can forward the connection to our client, and we can see it in a browser. So there's a lot of things that are working there, and that's great. So let's now move on to the third test. And the next test is a variation on the previous test in that we're going to still create pods. However, we're going to do it in a slightly different way. In this particular example, we're going to create a deployment. Now, a deployment is a means of indirectly creating pods by delegating the responsibility for pod creation to a thing called a replica set. Now, in this particular case, we're specifying that we want 2 replicas, and we're saying that we want the Nginx image to be pulled and for a container to be started on that image. We're also creating an Nginx label on these pods so that maybe we can do fun things with them in the future. Okay, I'm going to start this running, and we'll wait for the replicas to be ready. Now, as I mentioned, the replica set is creating these pods, or is trying to create these pods. Now, given that the creation of the pods is delegated to the replica set, it needs a user ID to create those pods. It doesn't know what user initiated the creation of the deployment. And so, in this particular case, it uses a thing called a service account to create the pods. Now, there's a default service account in every namespace, and that's just as true of the default namespace as it is of any namespace. So right now, the replica set is using the default service account to try to create pods. And it doesn't look like it's very happy. So let's have a look at why. If we do, let's have a look at the replica sets. Here we go. This is the Nginx replica set. And what does it say? Error creating pods is forbidden, unable to validate against any pod security policy. So I mentioned the pod security policies before, and this is where we start to trip over those. So remember what I said about least privilege. Everything has to be authorized because effectively everything is denied until it's explicitly permitted. So what we actually need is a pod security policy that's bound to this default service account in order for it to be able to create a pod. So let's have a look at the script. And in the script, I actually give you a hint that you do need that role binding, and this is where you find the role binding. So let's have a look at the role binding. Okay, so the role binding that we need takes the privileged pod security policy. Remember, we saw that in the cluster role list earlier on, and it binds it to the default service account in the default namespace. So once we apply this, and we can do kubectl apply-f. Okay, so now we should have a role binding that permits that default service account user in the default namespace to create pods. So let's have a look. If we look at the replica set again, yeah, there we go. It's created a pod 3 seconds ago. Let's have a look at the list of pods. Great, there are our pods. So we fixed that problem. Now, if you want a graphical way to visualize everything that's going on, you can install and run a really simple open source tool called Octant. And in our documentation, we explain how to do it. Now, on the Mac, you can just simply install it using brew, which is what I've done. And I'm going to run it in a different tab. So I'm just going to type Octant, and it uses my existing Kubernetes context to log into the server. And then it just brings up a browser window and shows me everything that's going on in my cluster immediately, which is wonderful. So you can see the Q, I don't know even how you say that, the quad pod from our first experiment, the 2 Nginx pods running here, the replica set we were looking at earlier. We can see the config map we created earlier. And you can see the default service account and the role binding that we created. So I'm not going to deep dive into what Octant can do for you right now, but just to show you how easy it is to visualize this stuff graphically if that's your preference. Okay, let's have this exist in the background so that we can refer to it when we want to. Okay, and then we'll go back to our tests, and I think we'll move on to test number 4. Tests 4 and 5 are going to test important aspects of the networking in our cluster by creating services that expose the Nginx deployment that we created in the previous test. So let's have a look at the first one. Okay, here's the YAML for this particular service. Now you see it's very, very simple. It uses the Nginx label that we created on the deployment to match the service to pods, and it's going to expose port 80. So if we have a look at the script, Well, the first thing it does is it attempts to make sure that the deployment that's necessary for this service is created. Now, in Kubernetes, this is an idempotent operation, which means that if it already exists, this line basically doesn't do anything. So we can ignore that for now. This line here is going to apply the YAML up here, which is going to create our ClusterIP service. Now, a ClusterIP service, if you're unfamiliar with it, is a service that exists within the context of the cluster, but can't be accessed outside of the cluster. So one pod can access a ClusterIP service that's exposed by another pod. Then we're going to just display the endpoints and services that are available. And finally, we run a utility that creates the ability for us to curl in a pod in the cluster. So if we cat that, you can see it uses kubectl run, just like we did earlier, to run a Docker image that has curl in it so that we can curl within a pod in the cluster so that we can actually test our ClusterIP service. So let's run this. Okay, that ran pretty quickly. So as you can see, we have my ClusterIP service here, which is showing up as a ClusterIP service, and it has an IP address within the context of the cluster service CIDR that's specified as part of cluster creation. So now we can take the advice here and use curl in cluster, use this ClusterIP, and let's see what it does. It's going to create a pod with that Docker image. Now it's got to pull down that Docker image, so it's going to take a moment, but it curled it. It's clearly Nginx is running, so the ClusterIP service is running, so everything's good. Now let's move on to test 5, which is basically going to do the same thing, except it's going to create a service of type LoadBalancer, which is going to expose our Nginx service on an IP which is publicly accessible, that's going to be created by the HA proxy instance that we created in an earlier video. Test 5 is important because it's going to exercise the control plane plumbing between our Kubernetes cluster and the external load balancer that we set up earlier, which in this case was HA proxy. So let's have a look at the YAML and the script. Now the YAML looks pretty much exactly the same as the previous one, except it's explicitly declared as being a service of type load balancer, which is an instruction to Kubernetes to use the external load balancer that's registered with it to expose the service as a public IP. So now let's look at the script. The script is very similar to the last one. It ensures the deployment's created. It applies the YAML for the service. It then runs a different script called wait for external IP that just ensures that an external IP has been created before it proceeds. Then it displays the endpoints and services so that you can see what the IP address is, and then gives you a useful, helpful instruction on how to test it. So I can't contain my excitement. Let's actually run this and see what happens. All right, so it's going to wait a while to get the external IP. Actually, that was fairly quick. So now you can see my load balanced service is a service, and the external IP is this IP here. Now this IP is on the front end network. If you remember from previous videos, we know that because it has this .20 in it, and it's an IP address within the CIDR that we specified when we set up our load balancer in our vSphere cluster. Now it's interesting, we didn't look at this earlier, but you see the endpoints here. Now these are the internal pod IP addresses that the load balance service is load balancing traffic to, just as an interesting aside. Okay, so let's test this. We'll just copy that IP address and we'll type curl 80, and there it is. So we now have an external IP address that we can use to access our Nginx instances, and the HA proxy instance will load balance to those IPs. Great. And now that we've tested our network integration, let's move on with test 6 and look at our storage integration. Test 6 is going to check another important integration point between this Tanzu Kubernetes cluster and the namespace that it's running in. Now, if we look at the storage classes that are available to our Kubernetes cluster, you'll see K8s default storage. Now, You may recall that the vSphere admin, when we set up this namespace, specified that a certain storage policy could be used by the namespace, and they could specify limits on that storage. And they also specified how that storage policy would be manifested in Kubernetes clusters. And this is how it manifests. It manifests as a storage class. Now, the way in which we consume this persistent vSphere storage in this Tanzu Kubernetes cluster is through persistent volumes and persistent volume claims. Now, a persistent volume is basically just a VMDK. It's a disk that's created that a pod can write to. And a persistent volume claim is a binding of that persistent volume to a particular pod so that the pod can use it. Now, let's have a look at the YAML that we are going to use for this particular test. Now, it's a bit more involved than previous examples, but it's actually relatively simple. And you can see where this example comes from. Our persistent volume claim examples right here. So, first off, you'll see a persistent volume claim. Now, this particular persistent volume claim is one that will automatically create a persistent volume if one doesn't already exist. It will do that dynamically. So we don't need to specify the persistent volume itself. And we specified that we want this particular storage class, and we specified that we want 2 GB. So that will create a 2 GB VMDK and effectively bind it to the pod. We create a service to expose our MySQL instance, which is what this is, and then a deployment which will create MySQL and bind the persistent volume claim to it. Here you'll see how that's bound. And here you'll see where that path is mounted into the container which is running in the pod. So let's have a look at the script that's going to run this. Very straightforward. What it's going to do is it's just going to apply the YAML that we've just seen. It's going to wait for the deployment to be created, and then it will just show you the persistent volume claim that's been created and just show you the deployment. So let's run that. So now it's going to be creating the disk. It's going to be binding the disk to the Kubernetes node that the pod is deployed to, and then mounting that into the container that's running in the pod. There we go. Now that took a little bit of time, but as you can see, we have a persistent volume claim. You can see that it's bound. It has the capacity that we expected, and it's available and in use by MySQL. Now, just for fun, let's have a look behind the scenes at what's going on in vSphere here. So first off, I need to switch my network to the network that the VI admin can access. Let's have a look at my test cluster. Here we go, simple cluster. Now, that pod will be running on one of these hosts. And if we look at the hosts, we'll see the hard disk. There you go, a 2 GB hard disk attached to this node, which basically means that the MySQL pod must be running on that node. Well, if we delete the pod and delete the persistent volume claim, that VMDK will be detached and deleted. Okay, so we've covered tests 1 to 6. Now, tests 1 to 6 are tests that you can choose to run in any namespace, and we'll be coming back to those just to verify with a different user and a different namespace that we can run those tests a little bit later on. But let's move on now to test 7, which is going to verify that we can run a daemon set in this cluster. We're going to deploy a daemon set into our cluster. Now, a daemon set is a means of deploying a pod to every node in the cluster. And daemon sets often use pods with privileged containers that can be applied to the nodes and augment the capability of the node in some way by being tightly bound to the node. So let's have a look at the existing daemon sets in the cluster. Now you can see here the Andrea agent, which is a CNI agent, which is running on all the nodes. You can see here kubeproxy is running on all the nodes. And both of those daemon sets provide essential network capability for the cluster. You can see here the CSI daemon set is providing essential storage capability to the cluster. So what does a custom daemon set look like? Well, let's have a look. So this is going to deploy FluentD from this example here in the Kubernetes documentation that I've linked in the file. And the script is very simple. It's just going to apply that YAML and then just wait for the daemon set to be available. Now, this should work. Given that we've shown that we can deploy a pod, given that we've shown there are already daemon sets running, this should just work. But it doesn't hurt to verify it. Okay, now I've already run this once, so the container images are already loaded on the nodes, which makes it much faster to start. And there it is. There is our daemon set. It's up and running, and we should now be able to use its capabilities. Now, if we wanted to go to our Octant plugin, we could look at the nodes here. Here are the 4 nodes. It's showing that everything's healthy and happy. And we should be able to go to the namespace overview if we wanted to, and pick kube system. And there we should see our daemon set. Yeah, there we go, daemon sets. And there is our Fluentd Elasticsearch daemon set. And we can click on that and get some information about it. And it's showing here that it's running on each one of the nodes. So thumbs up for that. Let's move on now and talk about another aspect of networking that we haven't yet covered, which is Ingress and Ingress controllers. Let's talk about Ingress and Ingress controllers. Now, for those of you who don't know what Ingress is, I'm going to take a moment to explain it. Now, if you recall, a few tests ago, we deployed a couple of Nginx pods, and then we load balanced traffic to those pods using a service-type load balancer that we deployed to our cluster. Now, the load balance service told Kubernetes to get in touch with HA proxy and create a front-end and HA proxy with an IP address, a public IP address on the front-end network that we could use to access that service externally. So anytime you create a load balance service in Kubernetes, you get a unique IP address through which you can access that service. Now, Ingress is a similar concept, except rather than having an IP address for each service, it has a URL path on a single IP for each service. So the Ingress controller is the thing that owns the external IP address, and then each service is exposed as a path, as a URL path on that controller. Let me show you an example. So if I skip ahead to the test application that we're going to be deploying to our Ingress controller, you'll see that we create a ClusterIP service that routes traffic, actually load balances traffic to our Hello app. And then this Ingress definition here is going to expose that on /hello on the Ingress controller. So in order to access this, we'll use the Ingress controller IP and then /hello as the endpoint. Now, of course, before we go ahead and deploy this, we're going to need to deploy an Ingress controller. Now, the vSphere documentation gives you a couple of examples, one using Contour, one using Nginx. We're going to do the Nginx example. Now, it uses Helm, so you'll need to deploy Helm. I have deployed Helm. And if we look at the script, okay, you'll see commands in here from the documentation page that we just looked at. The first one pulls down the Helm chart. The second one installs it. The third one waits for the Ingress controller deployment to come up. And then we just show you some information about it. And if you want to see more detail, I've linked to the page where I took these commands from. So let's deploy this, see what happens. Okay, the first thing it's telling us is it already has the Helm chart downloaded. And then what is it telling us here? Okay, it's currently doing a job. It's doing some kind of admission job. And it's created a service account, cluster role, a few other things. Okay, that's interesting. Now, if we left this running for a little while, you would eventually see that it times out. It doesn't succeed. And in fact, we would expect this job to have already completed. So why is this not working? Well, rather than just telling you, I think we should explore why it is and figure it out. So let's get namespaces. Let's see, are there any interesting namespaces? No, there's no new namespaces that have been created. Okay. Any new pods that have been created? No. Now remember what it said that it was doing. Remember it said that it was doing a job. So we can actually do kubectl get jobs. Aha. Now, it looks like it's in the middle of trying to do a job, but it hasn't been able to complete it. So let's have a look and see why it couldn't complete that. Aha. Error creating pods because there's no pod security policy. Well, why is that? We defined a pod security policy binding earlier. We dealt with that. Well, the reason is because it's created a new service account. If we do kubectl get service accounts, you'll see it's created Ingress Nginx admission. Now, this service account doesn't have a binding for a pod security policy in this cluster, so it just can't create the pod. And if it can't create the pod, it can't complete the job. So we need to create a pod security policy binding for this service account. So I've actually done this for you, and in fact, if you look carefully at the script that I ran, the script that I displayed, I showed you in here that in fact I have created this ahead of time. So let's have a look and see what that looks like. All right, you'll see in here there's two service accounts I've created role bindings for. There's Ingress Nginx submission, which is the one we were just looking at, and then once that succeeds, it then uses the service account Ingress Nginx. And both of those need to have pod security policies because both of them try to create pods. So if we eventually this is going to time out. It's probably going to time out quite quickly, but let's just apply that. Okay, so now it's created those role bindings. If we go back here, let's just Control C and rerun this. Now, unfortunately, if you try to rerun a Helm chart, it basically doesn't like it because it's basically saying you're trying to do this again, and there's already a name of this thing. So let's delete what we did and then try and reinstall it. Now you see it immediately got past that first step. Now it created the jobs, and there it is. So this is the output of kubectl get deployment. So it's showing us the deployment is ready. And here, this is showing us the services that are currently in the cluster. So this service here is the external IP for the Ingress controller. So this is going to be the external IP that we use to access our Ingress endpoints. So the next thing to do is to deploy the demo app that we looked at earlier, which is going to just deploy a simple hello app, a ClusterIP service that load balances to that app, and then expose that as an ingress on this Ingress controller. So let's have a look at that script. Okay, this script is very simple. It's really just going to apply this YAML that we looked at earlier. It's going to wait for the hello application to come up, and then it's going to wait for an Ingress IP. Now, it's interesting, the Ingress object in Kubernetes can take a while to update with the IP address of the Ingress controller, which is a little bit weird because the endpoint actually works very quickly, but it is what it is. Okay, let's run this. And that should complete very quickly. Okay, yes, it did complete very quickly. So this is the external IP of the controller, and we should be able to just take that and go to here and hello. And there it is. There is our Ingress. Well, eventually the Ingress object got updated with the external IP of the Ingress controller, but we already knew that, so we didn't need to wait for it. But there you go. There's an Ingress running in an Ingress controller in our cluster. So now we've completed all of the major kind of what I would call the sort of plumbing type sanity test to just kind of make sure that all the fundamentals are working in the cluster. And the next thing we're going to do, if we go and check our list, is we're going to create a new user and log in as that user. Now, this is obviously, as an admin, is a very important task. We need to make sure that the users that are going to use this cluster can do what they need to do, that they can log in, that they have the right security policies to do what they need to do. So let's move on and have a look at that. Now let's talk for a second about user management in Kubernetes. Now, I'm a Kubernetes cluster admin. Let's say I have a developer called Bob, and Bob wants to get access to my cluster. Well, so I go to Google and I say, how to create a user in Kubernetes. And it comes up with this, okay, authenticating in Kubernetes. And I read down here a little bit and it says, okay, we have two categories of users, service accounts, which we've already seen, and normal users. Okay, great. How do I create a normal user? Okay, so Kubernetes does not have objects that represent normal user accounts, so normal users cannot be added to a cluster through an API call. So what do we have to do? So anyway, you read down here, and it's not all that straightforward to create a new user in Kubernetes. And in fact, it depends on the version of Kubernetes that you're using, how you might go about this. So for me, one of the real values of the integration with the vSphere is this single sign-on integration of users right the way through to the cluster that we've created. So let's have a look at how that works. If we switch to the right network, this is my admin network, and then go to vSphere, make sure that I can access that. Okay, I can. Good. Now let's go to administration, single sign-on, users and groups. And this is going to basically show the single sign-on that I have configured in this vSphere cluster. Now in this cluster, it's just what you would do if you're setting up a simple lab. It's just a local nested domain. But of course, in production clusters, you'd be connected to some kind of directory service where all your users would appear. Let's add Bob as a user. Okay, there we go, Bob de Bob. Okay, so now they're added. And we're going to go back and see what we need to do to give them access to our Kubernetes cluster. Well, thankfully, it's remarkably simple. If a user exists in the single sign-on directory service in vSphere, they will automatically be able to log into your cluster using their password. So let's have a look at what a login script for Bob might look like. So the way that Bob authenticates with this cluster is exactly the same way as the Kubernetes cluster admin authenticates with the cluster. The only difference is the user ID. So let's run this script. And it's asking me for Bob's password. Hopefully I get that right. And there we go. Bob is now logged into the cluster. It's really that simple. If the user exists in the vSphere single sign-on, that user can log into the cluster. Now you may think, wait a second. So you mean any user in vSphere could just log into any cluster and do whatever they want? No, because of the least privilege we talked about earlier on in the video. Actually, now that I'm logged in here, I won't be able to do anything. If I do kubectl get nodes, it's not going to tell me the nodes. If I do kubectl, actually let's use the sanity checks that we looked at earlier. If we do, let's try and create a config map. Bob can't even create a config map in this cluster, which is good. So, in summary, vSphere handles the hard stuff, which is the authentication. And the Kubernetes cluster admin is able to handle the relatively easy stuff, which is the authorization. So, the key question then is, as an admin, how would I authorize Bob to do something in this cluster? Well, the first thing I'm going to do is log in as the admin. Okay. Now, what I'm going to do as an admin is create a namespace. And the reason I'm going to do that is I want to compartmentalize the area that Bob can access. I don't want Bob accessing the default namespace or any of the other namespaces, just this one namespace that's going to be for them. So, kubectl create namespace ns1. Okay, I've created namespace ns1 for Bob. Now I need to create some role bindings to allow Bob to do some things in this namespace. So let's have a look at some that I've already created. Now you'll see in this YAML file I have two role bindings for Bob. Now a role binding applies to a specific namespace as opposed to a cluster role binding which applies to the whole cluster. And in this case the role bindings apply to namespace ns1, which is the namespace we've decided we want Bob to be able to access. Now this one defines a particular cluster role called edit. We'll have a look at that in a second. And that basically defines the objects that Bob can interact with in that namespace and the way in which they can interact with them. And then this one defines a particular pod security policy that is also a cluster role. So the cluster role links to the pod security policy, and the pod security policy is quite specific about the kinds of container that Bob can run in that namespace. So let's just deep dive into both of those things. So if we do kubectl get pod security policy and then cut and paste this. Now get with this gives you a nice summary of what you can do. So restricted doesn't allow privilege escalations. It forces containers to be run as non-root. And you can also limit the particular volumes that the container can mount. Now, compare that to the privileged one that the admin runs, and you can see there's a lot more. And actually, this caps here is important. This is Linux capabilities or Linux container capabilities. Not deep diving into that, but it's worth noting that there are a lot of capabilities that can be defined for specific aspects that a container can access of the host that it's running on. Okay, so that's the pod security policy. Now the edit cluster role, if we do kubectl describe cluster role edit, now you see the detail here. It defines every single thing that Bob can do with every single object in Kubernetes in that namespace. So it's very, very granular and very detailed. And this is a great starting point for you to define your own cluster roles if you want to tweak this at all. Okay, so having done that, let's now apply those role bindings for Bob. So if we apply, there we go. Those are now created. Now, I've actually put Bob's terminal on a separate screen, so it's a little bit clearer. I've also created Bob's own kubeconfig. Now, if I do export here, you'll see kubeconfig environment variable defined. That's really worth doing because every time you log in using the vSphere plugin, it will update the kubeconfig that's pointed to by this environment variable. And so it's good to just kind of separate those for each user. It's at least you don't have to do it, but it's good to do it just to kind of avoid confusion. Okay, so let's try and do some things. So first thing I'm going to do is to create the config map, our first simple test, and it hasn't let us do it. Why is that? Well, because we tried to do it in the default namespace, and it's proved that we're not allowed to do that, which is actually good. So if you want to use these scripts with a specific namespace, you can just add the namespace to the end of the command. Aha, that worked. Great. We were able to create a config map or a simple object in that namespace. So that's good. So let's move on now to the next test, which is creating a pod. Deploy pod into namespace ns1. Interesting. Okay, well, let's quit out of this and let's do kubectl-n ns1 get pods. Now you see it's having a problem creating the container. Interesting. So let's describe the pod and see why. Container has run as non-root and image has non-numeric user nobody. Cannot verify that it is non-root. So what we're bumping up against here is the pod security policy. Now, if you recall, as you can see, the pod security policy is very specific that a container must not be run as root. And unfortunately, the user ID in this container is such that the container engine cannot determine whether it's root or not. And so it's preventing us from running this. So this is a good opportunity to talk about how we might modify or customize an existing cluster role or pod security policy to achieve what we want. And in this particular case, as an admin, I'm going to decide that this particular clause is too restrictive for Bob, and so I'm going to change that. So rather than modify the out-of-the-box restricted policy, I'm going to copy it and make a new policy out of it. So the way that you would do that is you can do kubectl get pod security policy, put in the pod security policy, and if you do -o YAML, it will give you, oops, if you do -o YAML, it will give you the output as YAML that you can just cut and paste into a file. So let's look at what I've done here. I took the output of that command, I gave it a new name. This is VMware System Restricted with root. And I changed run as user. So the rule here is run as any. So I've taken away that restriction. In addition to that, I've created a cluster role called PSP : VMware System Restricted with root that points to the pod security policy. So when I deploy the role binding points to the cluster role points to the pod security policy. Okay. So let's deploy that. All right, both of those have been created. Now what I need to do is modify the Bob role binding to point to this new cluster role instead of the old one. Okay, so let's edit this. and change this to with root. All right, then we need to apply that. Okay, I think it wants us to delete that before creating a new one. Yeah, we have to delete it and reapply it. I think that's a security feature. Okay, so let's go and check on Bob's terminal and see what the pod looks like. Okay, well, it still hasn't created the container. Now, the reason for that is because Kubernetes is quite particular about the order in which things can be done. So if you modify a role binding after the fact, you have to delete and recreate the pod. So let's do that. Okay, so we've deleted it, and let's try recreating it. Aha, good, excellent. That has now created the pod, and we've moved forward. So the next step is to try to create a deployment. Now, who can guess whether or not this is going to succeed? Spoiler alert, it's not. So why is this not going to succeed? I thought we just fixed the pod security policy thing. What could possibly be wrong? Well, let's go and have a look at, let's do kubectl-n ns1 get replica sets. Let's describe that. Error creating pods is forbidden, unable to validate against a pod security policy. What? We literally just fixed the pod security policy thing. Well, if you recall from earlier on in the video, deployments don't use the user ID of the client to create a pod. They use a service account. So in this namespace, there will be a default service account. There it is. And this service account isn't bound to any pod security policy. So even though Bob is trying to create this deployment, Bob's default service account cannot create the pod. So basically we need something like this. It's a role binding just like the one we saw for Bob earlier that binds the pod security policy we want in the namespace we want to the default service account in that namespace. Okay, let's apply that. Okay, so now let's go and see whether that's had the effect that we wanted. Let's have a look at the replica set. Yes, it has. You see we have 2 pods that are running, and if we do get pods, we should see them. Now, why is this different to the pod that we had to delete a moment ago? Why do we not have to delete this deployment for it to pick up that new role binding? Well, the difference is that the replica set that we're looking at automatically continually tries to deploy a pod if it can't. And so it's automatically doing that deletion and recreation for us. And that's why we didn't have to do it. Now, it takes a couple of minutes to pick up the change and eventually get there, but we didn't need to delete and redeploy this deployment for that reason. Great. So we've been successful at deploying the deployment. Now let's try and deploy a service. Well, that was quick. That worked. So let's just run this with the cluster IP. Okay, interesting. That utility is not smart enough to know that it needs to create the curl pod in namespace ns1. Let's just try add-n ns1 and put in our IP. Good. Excellent. That's worked. So let's try number 5 in the correct namespace. So this is now going to try to create an external load balanced IP for our Nginx service, and it's successfully done that. So now we should be able to just follow the instructions. Curl external IP port 80. That's succeeded. Excellent. So that's great. Bob can now make use of that HA proxy that's been deployed to create IP addresses on the front-end network. And let's run the final test, which makes sure that Bob is able to create a persistent volume claim, which in turn should create a persistent volume that's associated with the cluster. Now, it'll take a moment because it has to create the disk and format the disk and then attach the disk and mount the disk. And there we are. Excellent. So we have a persistent volume claim that Bob is using, and it's bound to this MySQL instance that has been created in the namespace. Great. Now, if you want to clear all this up, I've got a script that does that for you. So you can just run sanity scripts cleanup and then the namespace. Okay, so let's go back to our admin view and just recap where we are in our checks. So we've created a new user and we've logged in as that user. We've created a namespace and we've run checks 1 to 6 in that namespace. And we've logged in as a non-admin user and made sure that they can run 1 to 6 as that user. Great. Now the final thing we're going to do is deploy and test Prometheus and then show you how to run Sonobuoy against the cluster. For our penultimate validation check, we're going to install a real-world application. In this particular example, we're going to use Prometheus, which is a popular open-source monitoring extension for Kubernetes. Now, there's a lot of information online in various blogs on what Prometheus is, how to install it, how to adapt your app to export metrics that it can consume. And I've boiled one of those blogs down into a couple of simple scripts so that you can quickly verify that Prometheus works in your cluster. So without further ado, let's have a look at what the first script does. So the very first thing we'll do is we'll open up the blog post, which is linked from the script. And the blog post goes into a lot of detail about what the various scripts do. In particular, they go through the role-based access control, much of which we've already covered in this video, how to deploy Prometheus itself as a service and a deployment, and then how to deploy an example app that exports some latency metrics. So I don't want to go into that in detail, and let's just run the script. So it doesn't take long for Prometheus to come up, and the Prometheus deployment will be available on an external IP. So here you can see the external IP, which is of service type load balancer. And you'll see down here, and actually up here as well, that it's exporting on port 9090. So helpfully the script tells us, go to a browser, put in this IP address, and look at port 9090. Now sometimes it takes a moment to load, and there it is. Okay, there's Prometheus. So that part worked. So now let's run the demo app that's going to export some metrics for Prometheus to consume. Now, before we go to the Prometheus UI to try to see if we can see the metrics from this app, let's just make sure that they're being published on the correct endpoint. So we'll follow the instructions here on the script, and we'll put the external IP :8081/metrics into our console. Great. So these are the metrics that are being exported from our application, and obviously they're kind of difficult to read and consume. So let's go here. I'm going to click on the classic UI because it provides me with a nice drop down. And look, there are our metrics. Now what we can do is we can look at any of these, duration seconds, for example, and we can graph that. And there you go. We're graphing all those metrics over time in Prometheus UI. So very, very simple. Once we're done with that, we can just run a cleanup script, which is in the scripts directory, and that will just take everything down again. So very simple, standing up Prometheus, standing up an application that produces metrics for Prometheus to consume, verifying that we can see all of that, and then just shutting it down again. Now, the final challenge is we're going to take Sonobuoy and install that against our cluster and run the conformance tests. For the final validation check, we're going to run Sonobuoy against our cluster. Now, Sonobuoy is a community-maintained test framework that allows you to easily run all of the end-to-end tests against your cluster, including conformance tests, which make sure that everything with your cluster works the way that the Kubernetes upstream developers expect it to work. So without further ado, let's go and figure out where to get Sonobuoy. So a Google search will take you quickly to this GitHub repo, and you can go down here and you can download the latest release. Now, given that we have a 117 cluster, I'm going to download the 117 version of Sonobuoy. So here is what I want, and here's what I want to download. Now, I've already downloaded that to my downloads folder. So if I extract it, it just gives me a simple binary called Sonobuoy. If I then run Sonobuoy, it's going to give me the help and tell me everything that I need to do to start a Sonobuoy run going. Additionally, the documentation in the GitHub is also informative and useful. Now, all I have to do is type Sonobuoy run, and I'm going to do --debug and --wait. I need to tell it to run it from the current directory. Now, Sonobuoy will just sit there churning away, doing its thing. And if you want to actually watch what it's doing, let's turn back to our good old friend Octant. So I'm just type Octant, and it's created a window automatically off screen, but I'll paste the URL in here. Great. Now you can see there's a Sonobuoy namespace that's been created, and we can see everything that's going on in here. So it looks like it's already running some tests. It has a daemon set running. This is yellow, so let's have a look and see why that's yellow. A lot of information here about this. Interesting. Error pulling an image. Failed to pull image. Okay, there's obviously some problem with this image. So let's just go and have a look and see what that might be. Okay, if we Control-C this, and let's delete the run. Okay, so let's do a Docker pull and just see if we can get that image. No, it seems like that image doesn't exist. And that is in fact the case. I went back a couple of versions, and the newest one that's available is version 1.17.9. So we don't need to pull that, but at least we verified with Docker that it's available. The way that we're going to tell Sonobuoy to use that image is to type Sonobuoy run, and then we're going to use v1.17.9, and then --debug and --wait. Made the same mistake again. All right. Now let's go back to Octant and let's see what it's doing. Good. There is a Sonobuoy namespace. Let's have a look at this end-to-end test suite that it's pulling down. Aha, it is now pulling the image. It successfully pulled the image. So now it should be setting up the test suite, and now hopefully it should be running the conformance tests. I have to say, Octant is a really, really lovely way of viewing this kind of progress, because it just in real time displays all the events for a particular thing, and that's really useful. Now, if you want to watch the Sonobuoy tests running in real time, Octant is a really good way of doing it. Just click on the cluster overview and you'll see namespaces coming and going as each of the tests are run, because each test is run in its own namespace. Here you can see a resource quota test being run, and very shortly, yes, you'll see that namespace being terminated as another test is run. Fast forward roughly 45 minutes and our Sonobuoy run has completed. Now all we need to do now is type Sonobuoy and status, and it will tell us that yes, the end-to-end tests that it was running, which include the conformance tests, have passed. Now you can get much more detailed results using Sonobuoy retrieve. There's a lot of information on the GitHub about how you do that, and I'm not going to dive into that, but suffice to say that this is the rubber stamp on your cluster that really it's going to do everything that you expect it to do. It's set up correctly, and it should be good to go. Well, thank you so much for going with me on this journey exploring your Tanzu Kubernetes cluster. I hope you found it informative and useful. And it's worth noting as well that about 80% of what I've covered here is applicable to any Kubernetes cluster. So just as general education about Kubernetes, I hope it was really helpful.